Hello, everyone. Last time we've learned about Boyle's law, Charles' law, and Gay-Lewis 6, and many variables. So we have a law that's called combined gas law, and that's what it does. It combines all the variables, the pressure, the temperature, and the gas. So one relationship that we can use. So P1 V1 over T1 equals to P1 V2 over T2. And we also use the Kelvin formula, which is T Kelvin equals to 273 plus T Celsius. We're going to just go over a couple of examples to apply that law. A gas at 110 kilopascal and 30 degrees Celsius fills container with initial volume of 2 liters. So you see pressure, temperature, and volume, so combined law is what we're going to use. If the temperature is raised to 80 and the pressure is increased to 440, what's the new volume? So P1, 110, V1 is 2 liters, P2 is 440, V2 we're looking for, T1 is 30, and T2 is 80. So the first thing we want to do is write the law down, combined gas law, and we're going to change the temperature from Celsius to Kelvin, adding 273. So that's the first two steps we have to do. And then we plug in the values. Okay, V1, P1, T over T1, P2, V2 over T2, and we're going to solve for V2. Now you solve for V2 by multiplying both sides by 353 and dividing both sides by 440. So you multiply by 353 and divide by 440 to cancel out these two. So 2 times 110 times 353 divided by 440 divided by 303 will give us 0.583 liters. So that's our new volume. Okay, same concept except that we added one more variable. Okay, a helium filled balloon at a sea level has a volume of 2.1 liters at 0.998 atmosphere and 36 degrees Celsius. If it is released and rises to elevation at which the pressure is 0.900 atmosphere, the temperature is 228 degrees Celsius, what will be the new volume? Okay, let's write this down. V1 is 2.1, P1 is 0.998, T1 is 36. Now P2 is 0.9, T2 is 28, and we're looking for V2. So we're going to convert Celsius to Kelvin, plug in the values. Okay, so we have this one, we're solving for V2 right here instead of X. I always put V2, I don't know why I put X. Okay, so we have 2.1 P1 V1 T over T1, and this is P2 V2 over T1. Now to solve for V2, we multiply both sides by 301 and divide both sides by 0.9 to solve for V2. So 2.1 times 0.998 times 301 divided by 0.1 divided by again 309 equals to 2.27 liters. That's the new volume. Okay. Now the new concept that we're learning is Avogadro's relationship, which is
an extension of Avogadro's principle is that 1 mole, 6.02 times 10 to the 23rd particles of any gas at standard temperature and pressure, 0 degrees Celsius and 1.00 atmosphere pressure STP, occupies a volume of 22.4 liters.
So same standard temperature and pressure. So it says Avogadro proposed an idea that equal volumes of all gases at the same condition, temperature, and pressure contains the same amount of particles. Okay, so at standard, once you see STP, you can get one more information that every 1 mole of any gas has 22.4 liter. Before we've learned that 1 mole of any element has 6.02 times 10 to the 23rd particles. But at same conditions of temperature and pressure, it also occupies the same volume, which is 22.4 liter, which is very helpful when we're solving a problem. So let's see what that means. What is the volume of 7.17 grams of neon at STP? So again, we cannot do anything with grams. We have to first convert it to moles in order to use the STP information. So from the periodic table, neon has a molar mass of 20.18. So we start with what's given, 7.17 grams of neon. Divide by the molar mass, we get the number of moles. Now to go from moles to liters, we start with moles, multiply by 22.4 liters. That gives us the volume at standard temperature and pressure. So there are 2 steps when you see standard temperature and pressure. First, you convert grams to moles, and then moles to liters. All right, we'll have more practice. If you have questions, let me know in class. Thank you guys. We'll see you next time.